about it as though it's a present phenomenon.
That's disingenuous. We do know
Yeah.
it's present and ongoing. We're testing it now.
Okay?
Why are you talking about?
We don't know
Why
if
are
it'll
you
exist
talking
in the
about
future.
Jesus who died 2,000 years ago? Like, why is that relevant to what happens today?
Okay. Well, what I'm asking you, when you talk about quantum entanglement,
Stop dodging.
you're talking about some type of what we would call continuity over time. That
You're
there are certain
evading.
events that have continuity. Now, do you believe when you invoke quantum entanglement and any other quantum phenomenon, do you believe that there is any at all continuity over
Stop
time in
evading.
terms of physical phenomenon?
Stop
Do you have an
evading
answer
the
to my question?
No, because you keep
He's
evading
scared
mine.
of you.
No, what I want to know is, do you believe that there's any continuity over
What?
time
No,
in terms
okay.
of physical phenomena?
Listen, I'm going to use an appeal to authority. I'm not a fucking quantum physicist. Sorry, a theoretical physicist. I can't answer this. I'm asking you yet to explain what quantum entanglement is.
Okay.
My opinion on what quantum entanglement is irrelevant. We're just going by the scientific definitions.
No,
by experts.
when you invoke quantum entanglement or any other physical phenomenon, whether it's at a quantum, an atomic, or a molecular level, that will be implicitly conveying that there's some level of continuity over time for those phenomena. Now, if you did not believe, if you didn't hold implicitly to continuity over time in terms of certain physical phenomenon, that would render any such statement of physical phenomenon, including quantum entanglement or any other quantum phenomenon, as meaningless. So it's going to require at least some continuity over time.
No, it's not.
Okay, well, if there's no continuity over time, then there's nothing that's static and where phenomenon are the same over time. Okay, so whether you're talking about quantum entanglement or that atoms have electron shells or whatever, you're referring to various continuity over time, right? Otherwise, it wouldn't mean anything. So you are invoking continuity over time. Now, what I'd like to know from you is what is it that provides for any continuity over time for any phenomenon, even at a quantum level? What would that be?
Stop trying to answer my question with a question, okay? Answer the question or back the fuck out. I told you, I'm not going to go down this rabbit hole with you. Either answer my question or you're going to.
I don't understand how quantum entanglement can be meaningful without continuity.
Well, don't worry. I'll explain it to you once you explain to me what quantum entanglement is. It's fine.
Okay, so can quantum entanglement or any other physical phenomenon at a quantum level be meaningful absent the concept of continuity over time?
Listen, okay, you keep asking me this question. Just answer what quantum entanglement is, and I'll hold your hand for the rest of it.
Okay, well, whether I could give you a good definition, I mean, I could read off of Wikipedia or pull up articles, but I'm interested is a deeper concept here, because there are different physical phenomena that we could both invoke, including quantum entanglement or other quantum phenomena. All of these descriptors of physical phenomenon are going to require that there is continuity over time, okay? Otherwise, quantum entanglement or any other physical phenomenon doesn't mean anything. So it's going to require that there's some level of continuity over time, because either you believe that any physical phenomenon at a quantum level requires continuity over time, or it doesn't require any continuity. Which do you believe?
All right. So are you done now, Darth? Because you keep taking
that was a question.
It's a yes or no thing. Are you done so I can answer, or are you going to keep interrupting?
I'm waiting for an answer.
All right, cool. That's irrelevant. Okay, I'm asking for you to explain what quantum entanglement is. Yeah, you don't answer my question with a question.
I'm waiting for my answer. Does quantum entanglement require continuity over time?
No, because do you want to know why? Because it doesn't follow the regular rules of logic, as I tried explaining to you earlier. That's why you don't need to ask me this question. It's an irrelevant question.
Do you realize how you just fell on your sword there?
No, because I just told you how it doesn't follow the regular laws of logic.
Continuity over time.
Continuity?
Continuity over times. Continuity over times. Do you know what that means?
Okay, that's irrelevant. I just explained to you it doesn't follow the regular rules of logic.
Saying that's irrelevant is not a rebuttal. Now,
it is a rebuttal.
Do you know that without continuity over time, you cannot invoke
this is a non-argument.
A class. You can't invoke a class of phenomenon that will mean the same thing at one moment versus another time index. So you just said, no, it's not so much an argument. I'm pointing out the incoherence of your position. You said that invoking quantum entanglement, which is a class, okay?
It's not a class.
Does not require, okay, it is a class of phenomenon.
Ah, right? Okay.
Okay, if I said, for example, that there's a certain chemical reaction, right, that would be a class as well, as opposed to, I could talk about trees as a class. I could talk about explosions or chemical reactions.
So wouldn't agree.
Okay, these would all be different versions of classes. Now, what you're saying is that a class of things, and in this case, the class is quantum entanglement, that quantum entanglement as a class can be meaningful without the concept of continuity. Well, that's entirely fallacious, because continuity over time means that the class of things that is invoked is the same thing in one time index as well as in another time index. But you see, when you said that quantum entanglement or any other quantum phenomenon doesn't require continuity, what you're saying is it can be the same thing without being the same thing. So what you said is an incoherency.
No, that's right. Okay, because what you seem to think is quantum entanglement. So because I'm going to have to explain what quantum entanglement is to you, because you seem to keep denying it. Is you can have two photons existing in the same place at the same time. They are not the same photon, but it's there two places at the same time. Do you understand?
That's photons, what quantum entanglement is. When you talk about photons, does that which photons represents, does it stay the same? Does it have continuity through time indexes?
It can't have continuity because it's existing in two places at the same time.
No, I said the class of photons.
Oh my God.
Do photons stay the same as a class over time indexes?
Ask him what light is.
Well, it's not irrelevant because you just invoked photons. When you invoke photons at T1, does it mean the same thing as a class as photon in T2 or T3?
No, they're
different. You're talking about the same class?
Dread, do you want to take over for a bit because my mind's going fucking numb?
Well, you see, what I'm driving at is a foundational layer to your invoking of quantum entanglement. You're going to need the concept of continuity over time to talk about photons. Yeah, you do, because are photons a class, sir?
Christian atheism, all I need to do...
Are photons... I asked you a question. If you're going to talk past me, I'll just ignore you. Are photons a class?
It's not a relevant question.
Are photons... It's relevant to me. I want to know.
He talks in circles.
Are photons a class?
That is not a relevant question to what you were talking about.
It is relevant. He invoked photons. I asked you, are photons a class? And does that class, in terms of the properties and attributes, remain? Does the class continue to exist over time indexes?
It does not matter.
No, it does matter, because then
the laws of logic don't exist at that scale.
Okay, hold on a second. I'm not talking about the laws of logic right now.
But that's the argument.
What I'm talking about is when you invoke, you cannot speak without invoking classes of things. So if you say photons, all right, photons mean that there are different entities that are members of a class. They have a shared set of properties and attributes. Does the class itself remain the same over time indexes?
As far as we know.
Okay, so the answer is yes?
I didn't say that. I said as far as we know.
Okay, well, you do know that?
As far as we know, they seem to. They have in the past. I can't say they will.
Okay, so can you tell me what is it that secures that classes remain the same over time indexes?
I can't say whether it does.
I
can only tell you it has in the past.
Thank you. You've now given me the rope to hang you with.
No, because it's irrelevant
Yes,
as
you
to whether or
have.
not
You know,
quantum
no,
entanglement has happened.
saying it's
Doesn't matter.
irrelevant is a poor debate tactic. Now, when you say you don't know, see, here's what you don't realize. You just handed me the rope. When you said you don't know what secures that classes remain the same, then you are saying that classes remain continuous over time indexes because of I don't know.
That's not
your
what
position.
I said. Nope.
Careful,
Okay,
guys.
so,
No rules.
okay, so do classes of things remain over time indexes because of what?
I don't know if they will in the future. I just literally said we
No,
observed
I'm
that they
asking
have
you
in the past.
what.
I don't know if they will
I
in the
didn't
future.
ask you about the future. I asked you what has, what is it that provides for continuity over time indexes, that the set of properties and attributes for classes stays the same through the past? What is it that secured that?
I don't know. We just have observed that it has.
Therefore, okay, so you don't know what, if anything, secures the continuity of classes. Is that correct?
Again, still irrelevant to entanglement, but okay.
No, that's not an answer to my question.
I don't. This is off topic, though.
Do you know what secures the continuity of classes
I've answered the
time
question.
indexes
I'm not going
in
to
the
answer the same
past?
question 7 times.
I want everyone in the room to. I want everyone in the room to notice. I am simply taking what they are asserting and focusing on the classes that they are invoking and asking them to provide from their model of reality what secures for the continuity over time indexes, including the time indexes in the past,
but
that
this
the classes
is the difference,
remain the same over time indexes. And his answer was, I don't know.
Yeah,
Therefore, when you invoke classes through time indexes, whatever that frame of reference may be, whether it's the past, the present, or the future, what you are then saying is these classes exist as a part of your premises because of I don't know. So you are making unfounded claims that classes exist over time indexes.
No, I literally don't need to make that claim.
Oh, yes, you do.
All I need to do is show to you that quantum entanglement has happened and that it doesn't square with the law of identity.
Quantum entanglement or any other physical phenomenon. I'm going to ask you a question. Can you invoke any quantum occurrences without invoking certain entities that are members of a class?
It doesn't matter.
It does matter, because when you talk about quantum phenomenon, you're going to have, in order to speak at all, you're going to have to invoke entities that are members of one or more classes. Because if you don't identify that they're members of classes, then what you were saying will not be intelligible. So when you invoke quantum phenomenon, you're going to be invoking that there are entities. Are any of those entities in the quantum phenomenon that you're referring to, are they members at all of any class? Do you have an answer?
I mean, everything's a member of a class, if you want to put it in that way.
Okay, so the intelligibility and meaningfulness of your discussion of any quantum phenomenon is going to require that there are classes of entities. Is that correct?
There would have to be entities for anything, yeah.
No, that's not what I asked you. I said when you talk about any quantum phenomenon, including quantum entanglement, you're going to have to be invoking certain entities, and that those entities are members of a class. Is that correct?
Yes.
Okay, now, do you have a rational justification that there is something that provides for the existence of these classes and the continuity of these classes?
No, I just know they exist.
No. If you know the classes include an unconditionally non-dependent.
Sorry, you cut out. I didn't hear that.
I said when you know that these classes exist, are these entities that are in a class, are they absolute and non-dependent? Or is there being a member of the class dependent upon precursors?
I'm not interested in your rabbit hole because it's irrelevant
I'm
as to
not
whether or
rabbit
not
holing.
quantum
No, it's not a
entanglement has
rabbit hole.
happened,
It's
or
not
if
a
it
rabbit
breaks the law of
hole.
identity. It's
I'm
really
waiting
irrelevant.
for you.
I'm
No,
sure
you're
everyone here agrees it's
discussing.
irrelevant.
You're discussing classes of things.
Could you go ahead and repeat your statement? Because I could not hear you.
It's completely irrelevant as to whether or not Class A and B might change in the future or may have changed. All I need do in this argument is show to you that we have observed quantum entanglement and that it breaks the law of identity for any of the two entangled molecules or however many you've got. Like, let's say you've got 8. So long as it breaks the law of identity for just one of those particles, that means the law of logic is not consistently followed, which means not your argument. It's not even your argument, Darth. But it means Batman's arguments fall flat and don't work.
Okay.
That's the argument we're having.
What you're doing is you're segueing away from my question.
No,
now,
no.
In order to talk, in order to speak about quantum phenomenon, right? At all, whatever you speak, you're going to have to invoke directly or indirectly, referencing some classes. Now. You already admitted that in order to talk about quantum phenomenon and including quantum entanglement, you're going to have to invoke that they're classes, and you said classes are real. Now, do classes exist? Do these entities that are a member of a class, are they a member of the class because they themselves are absolute and unconditionally non-dependent, or are they members of the class in virtue of a precursor?
Can you please define what you mean by class? Because is a photon in its own class?
A class is an entity that has a shared set of properties and attributes with other entities from a common source, and that common source provides for the continuity. Now, in order for you to invoke quantum occurrences, you're inevitably going to have to invoke classes of things, as you have. You've mentioned photons. Now,
that wasn't me.
Photons, well, whatever. It doesn't matter what particles. You mentioned particles, right? Okay, are these particles at all members of a class? Because if they're not, then you're not going to be speaking meaningfully. So the bottom line is, for the intelligibility and meaningfulness of your invoking quantum phenomenon, right? It doesn't matter whether you're invoking quantum phenomenon or atomic phenomenon, but in this case, it's quantum phenomenon. Now, you're going to have to mention classes of entities. But in order for those classes to be meaningful, they're having those properties and attributes will either be absolute in themselves and unconditionally non-dependent, or they're being members of that class and having those properties and attributes will be derivative from a precursor. Which is it?
I mean, I don't know. I don't know why they remain constant.
Then if you don't know, then you don't know that the classes exist and are not just simply mere happenstance occurrence. Because classes could only exist if there's something. Let me finish. Classes can only exist if there's something that secures their classness. If you don't know what does secure the classness, then you're invoking that they are classes is without basis. So you see, your line of reasoning. First of all, you're appealing to provisional concepts in quantum mechanics, which could turn out these interpretations. There's 12 different interpretations in quantum mechanics. And as I quoted to you, David Tong said, we could be entirely wrong if we're looking at it from a wrong perspective. So when you say we see these things, you don't see quantum entanglement. Quantum entanglement is inferred from a series of experiments, so it is an interpretive. Now, I want to ask you a simple scientific question. Are all observations in empirical endeavors theory-laden?
What do you mean by theory?
Okay, do you consider observations as neutral, or are observations theory-laden where people interpret something based upon their network of beliefs about the background information?
Well, actual results for an experiment would be neutral.